Welcome to the Health Workforce Technical Assistance Center's webinar series. This presentation is entitled Data Visualization, Strategies, Tips, and Tools. It was presented by Matt Jansen on February 10th, 2016. At this point in time, I'm going to go ahead and turn the event over to our presenter.
Hey, thank you, David. So we're going to talk today about data visualization, a few different aspects of it. We're going to keep it pretty broad and general. I know that there's probably a wide variety of people in the audience, and you probably have a wide variety of things you want to communicate or analyze with data visualization. So I'm going to try and give a broad overview of some principles and concepts, some tricks that may be useful, and a broad survey of the tool landscape right now, kind of the types of tools that are out there, some of the pros and cons of different tools, and all of that. So, try and jump to the first slide. There we go. Here's a more in-depth version of that agenda. We're going to talk about why we want to visualize to begin with, and then dig into a few of those principles. This is, again, going to be a pretty high-level survey of that. And then the general tool landscape, some examples of some of the tools, and then the question and answer session where we can perhaps dig into some stuff a little bit further. So, a little about me. I am the data analyst at the University Libraries at the University of North Carolina at Chapel Hill. That is a somewhat intentionally broad title. I cover a lot of different things, including data visualization. And it kind of reflects the practical data visualization problem that many of you are probably familiar with, that to visualize data, you have to manipulate, find, combine, do all kinds of stuff to data. My personal background is in social sciences and statistics, and I've been supporting this kind of work in the library for 2 or 3 years now, or at least full-time. And we serve a student body and faculty across a wide variety of disciplines. We have some specialized libraries that cover certain things, law library, et cetera. But we generally are apt to see anyone from across campus. We may be talking to someone from political science, and then someone from the health side of campus, then someone from the humanities about something that they want to do with 18th century novels or something like that. So we do one-on-one consultations with students and faculty. We teach workshops on a variety of tools and on a variety of principal topics, kind of like the first half of today's presentation. And we do general work inside the library on that front sometimes. I may talk about that a little bit later. So with that, I'm going to dig into the visualization segment. So our first question is, why even bother visualizing data? It seems like a pretty good place to start. It's the real fundamental question that some people will ask at a group or organization where, especially if people have been doing things with more numerical analysis or statistics for a long time, they may not see a role for visualization, and or they may see a role for some visualization but not particularly complicated visualization, et cetera. So there is an argument to be made for visualization. There are also some drawbacks that we'll get to in a minute. So our first general reason why we might want to visualize is to provide the ability to analyze data and to provide dashboards for others to analyze your data. I've got an example here from Weather Underground. It's one of many weather forecast visualizations you can find on the web now. And it is an example of a fairly complicated visualization that shows a pretty wide variety of data in a pretty compact form, and is pretty easily interpreted by a member of the general public. It doesn't require special technical knowledge to understand. And that's often the goal with a dashboard. A dashboard is meant to be a tool for someone else to analyze your data in a way that they see fit. So this, as I'm sure some of you are familiar, this kind of dashboard will often allow people to interact. This particular dashboard will allow you to show different periods of time, different measures through the customization menu, et cetera. Another reason we might want to visualize is to tell a story or to support an argument. This is perhaps one of the most famous visualizations of all time. It was created by Charles Joseph Menard in the middle of the 1800s, and it visualizes the march of Napoleon's army into Russia. So the width of the lines you're seeing going across the visualization are the strength of Napoleon's army, and you can see it very clearly dwindle over time as the temperature drops. So this visualization combines several different things. It's pretty well done, and it includes a fair amount of text, which is an important point we'll return to a little bit later. The idea that your visualization is often something that is in support of and should be well integrated with the text and other arguments, other evidence that you have. That could be numbers, that could be text, that could be tables. And that's really the kind of idea of storytelling. And that can be a very valuable place to use visualization. So our third point is a little finer, a little more technical, but all I really want to communicate with this is that basically human visual working memory does not have much capacity. This goes to the old idea of why phone numbers are only 7 digits or 9 digits or 10 digits rather long, because most adults can only remember about that many numbers. Now, visualization allows us to switch some of that memory of those individual symbols over to memory of patterns and things like that. It can be more efficient. It's something a little more natural for us. We don't have to go access different parts of our memory to remember what things mean. I'm sure many of you have had that experience looking at some complicated mathematical expression and trying to remember what this variable refers to or that variable refers to, or a complicated graphic and trying to remember what things refer to. And this will come back when we talk about color and other things like that later. Kind of, you don't want to have particularly complicated visualizations because then you start to lose some of this benefit. So we've given a few reasons why we might want to use a visualization. Unfortunately, or fortunately, depending on your perspective, there are several situations when a visualization does not make sense. One of the first questions you should always ask yourself when you're considering creating a visualization is, does this visualization beat a table? If you are making a bar chart with 3 different values in it, someone will be able to see a certain pattern to those values, perhaps, in a visualization. They can probably, in many situations, this to some extent depends on the pattern you're trying to display, but in many situations, the numbers themselves presented in a table will both take up less room in your text and give people more specific values. So it can be a more valuable, more powerful, and more effective way to communicate those values. Even a step further than this is asking yourself whether or not your visualization beats text. If you have 1 or 2 numbers that you're really trying to visualize, and this is something you might see more frequently in an infographic, you might have the option to just put those integrate those numbers directly with your text instead of having a blow up of a circle that relative to nothing else is the size of this value. Visualization also suffers from the general question of how do we perform dimensionality reduction on data. That's a complicated term, but basically the idea is we have data that we have 1 million observations of something, and we want to summarize that somehow for people to consume. One way we can very effectively do that sometimes is with visualization. Sometimes we can also do it with statistics. So statistics can offer a more delicate way of working with your data, a more subtle way of presenting results. And sometimes visualization oversimplifies the issue. Sometimes a scatter plot of 2 different variables together is not showing everything that's going on. It's not showing that 3rd variable that's deeply affecting the other 2. So sometimes the visualization can be completely misleading, and it often is going to be most powerful when used in combination with all those other techniques. So the textual context, again, is important here of what you're putting in around your visualization. You may be able to alleviate some of those problems with textual context. And all of that said, the models never tell the whole story. This goes back to the old saying that all models are wrong, but some models are useful. Models not telling the whole story is not a bad thing. We generally are hoping that our model or our visualization is removing some of the noise so we can get a better feel for the signal behind the data. This is thinking of a scatter plot with a regression line through it. Of you have points that are all around it, and you can discern this overall trend and use that to extrapolate or plan or draw conclusions. That can still be a very useful way of describing the data, even though it's not necessarily the perfect way to do it. So with that, I hope you'll agree that there is some usefulness to visualization. And now we're going to go through a few basic principles, some kind of ideas that can be useful to keep in mind as you're creating a visualization. Some of them have already been a little bit teased in the things we've talked about already. But with that, I'm going to move to accuracy and human perception. So, in general, if we want to maximize our use of that limited human cognitive ability, we want to be pretty effective with our, or we want to be efficient with the ways that we encode our data. And as many of you know, there's many different ways you can encode data, and you can kind of see these encodings in visualizations that we see rather frequently out in the world. You have on this plot on the right, we have length, which is basically how bar charts communicate data. We have slope and area, which is basically how a pie chart communicates data. As you can see, that this kind of analysis is what underlies the idea that pie charts are usually less effective than bar charts or scatter plots or similar graphs that are using mainly geographic or spatial position and length to communicate data as opposed to area, volume, slope, etc. That said, maximizing accuracy may not be your only goal. Sometimes you're going to have many different variables you want to put in a visualization, and some of them are going to end up in these less accurate categories. That's okay. That really is something, it's a way to think about which variables you want to put in which position, which variables need that very fine accuracy, and which ones don't. In a lot of situations, you might use something like area or density to show population of different areas. That can be very effective at kind of giving a weighting to people of, okay, these really big dots are for these heavier population areas, but they don't really need to know the ratio between the population of two different counties in this visualization that we're thinking of. Color can do that very similarly. Another general rule to remember here is that more dimensions generally implies less accuracy. And one way you can really think about this is that there's more dimensions for people to use. These circles on the bottom left of this slide communicate the values 1 and 2 in two different ways. So in the blue circles, the second circle is twice the area of the first. In the red circles, the second circle is twice the height of the first. Research has generally shown that people will often interpret areas much closer to a height distinction than to the area distinction, especially you start thinking about 2 to 3, 3 to 4. As you picture that going out in your mind, you can imagine how these ratios of different sizes becomes very difficult to distinguish. We get a lot more area with just a little bit more radius as we get higher. So this can be a very confusing way to communicate data if you need that fine accuracy. This gets, as you can imagine, even worse when you go to volume, and that's one of the stronger arguments against the old three-dimensional Excel bar charts and such, or even worse, pie charts. So here's a few visualizations that communicate the same quantities. These are all pretty common visualizations. One you may not see quite as much is the plot on the bottom right with the dots. That's called the dot plot. It's really a way of trying to move even further to that position distinction than the length distinction of the bar chart that's listed above it. And you can see in these examples that the blue and the green areas are very close in size. if you look at them in the pie chart, it's very difficult for you to tell which is bigger. If you look at it in the bar chart, it's very easy to tell which is bigger. It's also easy in the dot plot, and it's even easier, arguably, in the table. So this is a situation where we might want to use a table instead of another visualization, or if not a table, we probably want to use a bar chart or a dot plot. As a bonus on this slide, I'm not going to go to it, but you can revisit this later. As David mentioned in the chat, these slides will be available after the event, but that blog post contains 45 different ways that were figured out to communicate two different quantities. So there's a lot of different ways you can encode data. There's a broader point to that as well, that even though there are lots of novel and interesting ways you can determine to communicate your data, they may not be useful. If they're not standards in your field, or if they're not standards globally, things like bar charts and pie charts that most people, your average person on the street can understand, then you can't necessarily count on someone being able to easily use it, and therefore you're losing some of that effectiveness with that limited human visual memory. Another useful principle to keep in mind as you create a visualization is the idea of preattentive processing. Preattentive processing is really about what pops out in a visualization. We'll talk a little later about a way to detect this in your visualizations or in other people's visualizations. But one interesting way to think about it is really with survival instincts. So you can imagine a primordial man running around in the jungle trying to keep an eye out for predators or tigers in the bushes, what have you. And we have certain visual cues that will pick up on things that are different than other things that stand out. This is also, in a more positive sense, something that was supposedly part of early human hunting, of being able to see from a distance and being able to track things that stood out from the rest of the landscape. So we can leverage that to make certain parts of our visualizations stand out to people, certain elements be reinforced in our arguments, etc. So as an exercise, we can look at this block of text and look for the sevens in it. I'd argue it's a reasonably difficult task. It's something that you can certainly do. The information is all there, but it is not a particularly easy task. We haven't done anyone any favors with using their visual memory more effectively. So here's another example where it's a little bit easier. We can see that the reds are different than the black numbers, so we can pick out the sevens. We can go through and tally them up much quicker. An even easier way to do this is to use different levels of saturation. So the darker sevens stand out much, much, much more strongly against the gray background. This is something that you can use. For a great example of this is with grid lines. Often if you are doing a visualization and you want to have a grid line for people to be able to refer to where exactly things are on your axes or other scales, you probably want those grid lines to be somewhat grayed out, somewhat less colorful than your data itself. Your main principle here is that you want your data to stand out, and you want your data to be the first thing people see, and the patterns in your data to be the first thing that people notice. So I'm going to talk about a couple of different distractions you can get rid of. This ties in very nicely with the grid lines discussion we just had. So this comes from Edward Tufte, who is one of arguably maybe even the biggest name in data visualization. I've got a few of his books listed at the end of this presentation if you'd like to learn more. But one interesting idea he has in one of his earlier works is this idea of a data ink ratio. And it really is exactly what it sounds like. It's the ratio of the ink that you use to encode your data to the total amount of ink in the visualization. So you can think about a lot of different visualizations that might have a whole bunch of fluff around the edges. Tufte calls that chart junk. And this visualization on the left at the bottom is a great example of it. It's using a bunch of different textures and colors, and the colors between the different bars really aren't all that useful because they're just doubly encoding the the textual information of which category each of these bars represents. And if you go to the link at the bottom of this page, it will actually show you an even further transition, taking it even beyond the visualization on the right. So the visualization on the right is using some of those preattentive principles to focus us in on bacon for reasons that I'm not 100% sure of, although who can argue with bacon? And there are ways that you could take this even further and make this an even simpler, less ink-intensive visualization. Important point here is that, again, this is something we talked about earlier, you don't have to maximize this completely. You want to do this within reason, you want to do this with an eye towards your audience, towards the standards in your field. Moving just a little bit further along and making this a little bit more data and a little less extra ink can go a long way. If you go to the full extent of this, you can end up with some pretty strange looking graphs that are perhaps difficult to interpret. So there's definitely those who argue that this can be taken very, very, very too far. And I think there's definitely truth to that. So you want to kind of get an idea of where you fall on this, and the progression at that link is an interesting thing to look at, because I think most of us can agree, and most of us have learned over the years that the type of graph on the left really isn't that great. This is the kind of thing I think about when when the Office suite first came out, and you have all these added features coming out each year. And people are excited about these, oh, I can make these different colors, I can make these cool backgrounds. It makes me think of clip art to some extent. And people went a little overboard with it for a while, and I think people have moved a little bit further back towards the more effective visualization on the right. But it's still something good to keep in mind. This is an even simpler distraction, but it's an extremely common one. Text orientation. So the way in which your text is oriented to your visualization is important. You want to have obviously the text be very clearly linked with each element that it's describing, and that can be a challenging thing to deal with in something like a scatter plot where you may want to label some things, etc. But even in this very simple view of this bar chart, you can notice that if you look at the chart on the bottom left, most of us will instinctively start turning our heads to read the text. It's pretty difficult to read the text vertically without kind of trying to turn your vision, even if you don't turn your head too much. The angled text is a little bit better, but the horizontal text is clearly the easiest to read without taking your eyes off the data. And really this goes back to that idea that the central thing in each of our visualizations should be the data itself. We want the context and the grid lines and axis labels and things like that to be somewhat in the background. We want it to be there, we want it to be legible, but we don't want it to be something that overpowers the data itself. So this is one of our last bits of the principles. Color. Color is a pretty deep field. There's a lot of people who are doing interesting research in color. I'm going to give you just a few takeaways and really leave further investigation to you if you're really interested in color. So the first rule of color is not to use the red-green palette. This was a seemingly default palette in Excel several years ago. It's not the case anymore. I think this has been integrated into a lot of software packages. It has been in virtually all the packages that we will talk about later today. But red-green is the combination of colors that is most indistinguishable to the most common forms of color blindness. So, and that's a fair percentage of the population, and it is something we should try to design our visualizations around. There are other ways you can vary colors. We saw earlier with the preattentive processing, the darker, firmer colors versus the softer colors. You can vary in a few different ways other than just the colors themselves. Another great takeaway from this is just the second point on this slide, get it right in black and white. So color can bring some very effective tools to your visualizations, but really you want it to be one of the last things you build in. You want to get a black and white or a blue and white or a whatever color and white visualization pretty well on its way, and then add color at the end. You want color to be something that perhaps isn't incredibly necessary. That usually prevents you from doing something like the example I have on this slide, where someone has doubly encoded these states, which are, again, vertical and hard to read, but they've doubly encoded them as colors, which just distracts you from getting any sort of pattern out of this data or from looking up the data. It makes it very kind of loud and distracting. So don't use color unless you have to. If you do need to use color or want to use color, Color Brewer 2, which I've linked on this slide, is a pretty powerful tool for picking out a palette that will be either good in terms of progressing through colors. One other big takeaway that I haven't explicitly listed here is not to use the rainbow color spectrum unless it's a standard in your field. The only color scale, rather, that is widely understood in my experience is the precipitation scale for weather forecasts. Outside of that, most of them are pretty field specific, and some of them make perfect sense. I mean, if you're a physicist and you're looking at something that really is about these wavelengths of light and all that, it may be a perfect way to visualize your data. But in most other fields, having 2, 3, 4 colors in a color scale that will progress through one color after the other doesn't make much sense because there isn't really a natural ordering to colors. You really are going to want to have one color from light to dark, or you're going to want to have maybe one color from dark to light and then another color starting there and going from light to dark, or vice versa. So you really want to have a pretty simple color scale if you're going to use one. Color Brewer 2 will help you select a color scale like that, and will give you all the standard codes to bring that into different software. So I'm going to give you a couple tips and tricks. These are going to be pretty quick, pretty broad. So this is very simple, but in my experience, not nearly enough people do this. If you're going to create a visualization, a great place to start is with drawing a picture. It really starts to get an idea of what data needs to be there, what things you're looking for when you're going to look at this, what expectations you may have in the data. And it can be really, really valuable when you actually go into the software, especially if you're not very familiar with the software. It gives you a target to go for that is static. Often if you have this general idea in your head, it may morph as you kind of work through the software and struggle with the software. Starting with a goal that you've drawn out is pretty easy. It's accessible to everyone. If you're working with a team to create a visualization and you're the one who's going to have to do all the software work, I sometimes find myself in that position inside the library. And I'll bring out pieces of paper with some different colored pens and have us all kind of work on drawing some pictures as a group. It's accessible to everyone else and really gets people involved. And a lot of people often have a fair amount of fun doing it. I've also listed the Dear Data project here. It's an interesting thing to take a look at if you're interested. It's a much more kind of design-oriented set of visualizations. They may not be optimal from an accuracy point of view, but it's an interesting project of two designers who sent each other visualizations via postcards, tracking different things in their lives each week for, I believe, a whole year. Next up is the Squint Test. This is basically looking for preattentive processing, and it's also extremely easy. Once you create a visualization, or in this case, a dashboard, you can just squint at it. And when you do that, you're going to lose a lot of the text. You're going to lose a lot of the finer, softer lines, like hopefully our grid lines and things like that. And you're going to see what patterns stick out when you glance at it. You're going to see these red colored dots that draw your attention. And you're going to get some idea of what a person who's sifting through your website or your report is going to see as they glance at this visualization. Is it going to be something that has some pattern in it that draws them in, or is it going to be just some garbled something that they don't really care about? It's not perfect, but it is so easy, it's hard not to do it once you know about it. So I would definitely recommend using the Squint Test on visualizations. So that's our last little trick. Small multiples, or trellis plots, or these have several different names. I like small multiples because it's very easily communicated between different types of visualizations. And the basic idea is, instead of cramming several different variables into one visualization, so at the top here we have these stacked bars that show these different health measures, which, sorry, are not very uplifting health measures, but they're more effectively visualized in the bottom in virtually the same amount of space by moving into several smaller multiples of a single graphical type, as opposed to this one graphical type that is cramming it all in there. Again, this kind of goes to a get it right in black and white mentality of not necessarily using the color if you don't have to. And it can be much more effective, and often is more effective, to move to the small multiples situation. This also, in this particular example with the stacked bars, we can very easily see the trend in severe housing problems in the red parts of the bars, because it has a common reference. None of the other parts of the bars will have a common reference, so it is going to be difficult for you to see what the trend in green is. It's interesting to see that excessive drinking peaks for Iowa and is reasonably flat throughout all of these as the others go down. It seems like excessive drinking is not really particularly strongly related to these other variables. Looking at this, it's harder to pick that out of the visualization itself on the top. Another way to think about this is to remove unneeded variables. So sometimes you'll be playing around with this and then realize there's not an interesting pattern. This could be excessive drinking here, where this maybe isn't useful or interesting to your viewers in this presentation. So with that, we're done talking about some of the basic viz principles. That is, again, a very high-level sweep through a lot of different things, and there's a lot more that you can read and learn about all of those. At the end of the presentation, I'll have some books and other resources you can look at to learn a little more. I'll also say that there's a ton of blogs and other stuff out there that do a great job of presenting and talking about these things. So if you want to learn more about any of these things, there definitely are places you can learn a ton more about them. So with that, we're going to start talking about the tool landscape right now. So I've broken things into 5 different categories for us just for efficiency here. There's spreadsheet-based tools. This is your Excel type things. There's in-browser tools, and by that I'm referring to visualization tools that you can use on the web in your browser. You don't have to download extra software. You don't have to do anything extra. That's usually pretty accessible. There's business intelligence tools, which is the category I'm going to include Tableau with, if any of you have heard of that. Coding-based tools and design-based tools. So one of the things, we'll return to some kind of general overlook between all of these different categories at the end of the webinar. But one of the things I just want to kind of tease at first is that there's going to be a trade-off with all of these tools. That the easier tools generally come at a cost of being less flexible. So the tools that are most easy for you to pick up and use often have a lot of the decisions made for you. That's why they're easy to use. If you're going to create a visualization, we've already talked about a lot of different ways that you could change an individual visualization and ways you could communicate a single quantity. We had that link to that 45 different ways you could visually communicate 2 quantities. There's a lot of options out there. If you have a simple tool that's very easy to use, it's generally going to be because most of those options have been eliminated or made very difficult to access for you. So there's a trade-off there. With that, we'll go to spreadsheets. So I'm sure virtually everyone in this webinar has used Microsoft Excel or a similar software package before. This is really where a lot of data in the real world gets collected. and it's often where your first basic analyses are done. Most people already have it, and it's generally pretty secure. It's not going to be web-based. It's going to let you create something with the tool you already have. So it really has some benefits there. Unfortunately, it's not particularly flexible. Excel has, with each version for the past couple versions, gotten a lot better at doing visualization, and even has some dashboarding tools built into it now, but they're generally not quite as strong as some of the other options that are more specialized towards visualization. At the end of the day, Excel is a spreadsheet program that will do spreadsheets, allow you to enter data very nicely, has some really cool tools for keeping your data standardized as you input it and work with it in some ways, but it is not going to be the best visualization tool out there for a lot of different types of visualizations. That said, that may be all you need. You may just need to make some bar charts. You may just need to go in there and make the grid lines in Excel a little bit lighter and do a couple things. You can make it look a little nicer, change the color scheme maybe a little bit, and get a very nice looking graphic that you can create with tools you've already got. So a next step up from that is moving to something that is a little more oriented towards visualization. So these are your in-browser tools. This is a picture of Plotly that I have up for this slide. And you're generally going to upload your data, often from an Excel document, into one of these tools and use it to create or manipulate a visualization. These tools will often allow you to, almost all of these tools will allow you to export your data locally, but also to post your data online. A fair number of them are going to involve your data being made somewhat publicly available. And it's important to remember that even the more secure tools that post online, if you're going to create an interactive visualization on the web, your data is public to some extent. Either to the extent that someone can come in and look at your data, they can look at your visualization, and there are a few tools out there that will actually take a static visualization and turn it into data, but or approximate it into data rather. But they can also hover over your individual points and see the values, and they could theoretically pull the values out from there. Another important thing to remember is that to be interactive, these visualizations have to have access to the data itself. So whatever level of disaggregation of data that you've put behind one of these visualizations is going to be somewhat available behind it because it needs to be there for interactivity. So there's a few options here that I've listed. Plotly is just the one I've shown a picture of. They're pretty similar in a lot of ways. One of the weaknesses of these tools is generally that the data is going to have to be in a very specific format. You may have to do a lot of your data manipulation and changing beforehand, and it's not going to be incredibly flexible with your data once it's in. In a lot of cases, it's going to be significantly less flexible than Excel. Some of these tools are also very specialized towards particular uses. Plotly does a fair number of different things, but most of its user base is scientific, or at least on the public side. So it does have some quirks. Tools like Timeline.js are very much oriented towards things that are going to be in a timeline format. And some other tools like Raw are really trying to do tools that are not readily available in something like Excel. So they're going to be somewhat more fringe graphical types, which is useful and interesting, but is also a little bit more difficult to interpret for a lot of people and limits its functionality. And really, at the end of the day, there are more and more of these tools each year, and it's very difficult to keep tabs on which are currently in use, which are still being developed or supported, and which are starting to die off. Some of you may have heard of IBM's Many Eyes, which seems to be slowly going defunct over time. So it really is sometimes difficult to keep a track on this space. So one important subspace of the in-browser community is the mapping tools. And the real two big players here that I'm going to talk about are ArcGIS Online and CartoDB. They both will allow you to pretty easily make very nice looking maps with multiple different layers in them, different base maps. They have a lot of very map-oriented functionality. and you can build things on top of them. Here I've got a picture of something that we built at UNC that gives patrons access to a whole bunch of oral history interviews about desegregation in North Carolina. So this is kind of an early version of it, but each of these points on this map links to a recording and also to a transcript from an interview with an individual who's involved in these processes. So it's designed for classroom teachers to work with. So there certainly is some flexibility with these tools beyond mapping, but everything will be map-oriented in some way, shape, or form. It's difficult to have other types of visualizations, et cetera. These are going to be, in most cases, the most flexible and most powerful map-oriented tools, but sometimes the full benefits of it are really going to require you to be doing some of your work in ArcGIS or in the open source version of ArcGIS, QGIS, or the alternative to ArcGIS. Those of you who use statistical software can think about SAS versus R here. So that's sometimes a limitation, sometimes a really big benefit. I know speaking for us, we have a pretty strong set of GIS librarians here in our libraries. So we have a pretty big strength with doing all the GIS work behind one of these. So it can be a very powerful tool for that. If you don't already have that in-house, it can be more difficult to use or more difficult to use to its fullest extent. So business intelligence. It's kind of a interesting name I've given to these. These are SAS' tools, ClickView, and Tableau. Tableau is kind of the, in a lot of ways, the biggest player in this space right now, or at least as I see it. And Tableau is pretty easy to use. It's frankly a lot of what we end up supporting here at UNC because it is accessible to your kind of undergraduate. Your undergraduate who's non-technical, who doesn't want to learn how to write code, but wants to create something that's not quite Excel either. It's a pretty flexible tool. What I've got here, and you can click that link when you get a hold of the slides and go to the interactive version of this, but this would be an interactive dashboard about drug poisoning in the U.S. There are different tabs at the top, so you can progress through different elements of data. This goes to the idea of telling a story or making an argument with your data. And you can use some of these filters at the bottom right. There's generally interactivity between individual visualizations. You click on one thing and the things that you've highlighted in one visualization will be highlighted or filtered down to another. There's a fair amount of flexibility. There's pretty good mapping stuff built in. The interface to build all this is point and click, which is very accessible. And a lot of them are competing pretty strongly with each other right now. So there's a lot of updates, a lot of support. There's, especially recently for Tableau, there's just been a lot of buzz and things like that, so people have started to hear about it. One of the cons of this is generally going to be one of the more expensive options. And this is especially true if you are if you're going to use data that is sensitive or needs to be kept secure. If you're going to use data that can be made public, for something like Tableau, Tableau has a product called Tableau Public. That's what this image is from. And that would allow you to share data publicly with the world. Anyone would be able to see it. You would be able to embed it in your website, et cetera. But your data does become public. And there are some limitations on that. If you want to store more than 10 gigs of data, then you need to get a paid-for license. But other than that, it's free. And the software is free, so it's a quite powerful tool in that space. But if you want to use sensitive data with it internally, it gets to really a space where the other people who are paying for this to be used internally are large companies who are doing sales analyses and things like that, and often have pretty sizable budgets for this kind of business analyst type of work. So your large server implementation of Tableau that would be secure would be rather expensive in most cases. There's also some limitation here, and this is starting to diminish a little bit, but in the past, the user communities around things like Tableau have been very business-oriented, so a lot of the examples and problems that are being resolved and people are thinking about and working on are oriented towards analyzing business data. A lot of that overlaps with the kind of data analysis you might do in academia or in health work, but it's not always quite the same. So it's sometimes hard to find people who are running into the same problems as you are. That, like I said, is something that's diminishing. So now we move into our somewhat more fringe elements with the coding library options. So the coding options are generally going to be free or very nearly free. You will have to host the things that you create with the coding, but the languages themselves and the packages that are used to create visualizations in them are generally freely available. These are going to be the most flexible tools available. These tool sets will allow you to change all these different parameters to make all kinds of different interesting visual types. What I've shown here is an example from the D3.js package. D3 stands for data-driven documents, and it's really kind of the leader in the online interactive visualization space. There's a variety of packages out there for R, Python, etc. that can do some similar stuff. So it can be extremely powerful, very flexible. It has very obvious cons. You're either going to have to spend the time to learn this yourself, or you're going to have to hire someone who already knows how to do this, and that can be expensive and time-consuming. With some of these, you're going to ultimately need to learn a few different languages to work your way all the way through this, or perhaps learn some Excel stuff to collect your data to move it into R or Python to do your analysis, and then to create a visualization itself, maybe in JavaScript or D3. And then to move that to the web, you're often going to need to use some HTML, some CSS, etc. All these different languages, you end up with the stack idea of computer programming. So it can be very time intensive. It can be very rewarding. It's the kind of thing that's challenging, and then when you get something right and it works the way you want it to, it feels great, but it really comes down to whether or not your organization has the time and energy to put into building these from scratch. There's also an element here that if you don't need this level of flexibility, if you want some interactive bar graphs and scatter plots and pretty standard visual forms, you can probably find a tool that will do it without forcing you to write code. One of the benefits of code on the other side is coding is much better for reproducible work, if that's important for you for grant purposes or for research purposes. If you're writing something in R, you can give someone the exact code that you used to create whatever you created or do the analysis that you did. If you're working in Tableau or Excel or something like that, you're clicking in menus, you're dragging stuff around, you don't necessarily have this precise list of steps that a code document is going to provide. And last but not least, there's the design-oriented tools. These tools really aren't extremely oriented towards data itself. They're not going to be particularly easy to create individual graphics with always, but they are very powerful tools for making really nice, polished-looking end results. So the big player here is the Adobe Creative Suite. Inkscape is a kind of free open source alternative. They're very aesthetically oriented. They have a lot of flexibility for color, positioning, etc. Very nice finished publication looking results. And they can be combined with other tools. You can create a visualization somewhere else and then move it over and continue working with and cleaning it up in one of these design softwares. The challenge is that it's a somewhat different mentality. It's very design-oriented. It may require two different people to work on this, or it's a somewhat different skill set than some of the other work. And really a lot of the work that comes out of this is going to be oriented towards static visualizations, which may or may not be a benefit to your organization. So that's the general overview of the tool environment. Again, as I said at the beginning, the easier tools, those in-browser tools, come at the cost of being less flexible. The fancier tools are often more expensive, except for the free tools that are coding-oriented, and those tools are perhaps not really free when you take into account the amount of time and energy and perhaps hiring someone, a developer, et cetera, to actually use them. So there's certainly a trade-off there that has to be kind of decision made in-house. There's an ever-growing spectrum of tools in between these kinds of extremes. There are things like Plotly. I didn't maybe give it as much credit as it's due. It creates its visualizations, but it also allows you to tie in with things like R and Python. So it can allow you a little more flexibility than your average web-based visualization tool. But at the end of the day, your most effective results are often going to come from combining a few tools, even if it's just Excel plus X, and ultimately knowing and understanding your data. So that kind of being literate and conversant with your data is really what's going to underlie the most effective visualizations. So with that, I am through with the slides and on to questions. I'm just going to very quickly preview here. These will be in the slides. These are some galleries of some examples that are actually interactive. I know this is a static presentation and you weren't able to get the full effect of all of these things. These also list a few of the other tools that are out there that I didn't mention today. I've also got some books listed here that are good reads for kind of getting an idea around some of the principles and theory and some practical things that can be of importance. And with that, I'm going to move to questions.
Thank you, Matt. That was very informative. We'll go ahead and start the Q&A session now. Once more, you may ask questions using the chat panel on your screen. And please make sure you direct your questions to all panelists. Matt, we had a question that came in earlier, which you might have saw. Perhaps you could be a little bit more specific on which of the in-browser tools are open source.
So that is really going to vary from tool to tool. I believe, and it's also varying over time, I believe a lot of them have gone semi-open source where they have code that then shoots the internet to actually create the visualizations. A lot of the code-based things are going to be open source, but really, unfortunately, you kind of have to do some research on individual things at a given time as to how open source they actually are. I believe Plotly has recently gone open source. Let me go back and see what else I mentioned back there. I'm not sure if Timeline.js and Raw are, but really that is unfortunately one of the things it's hard to keep an eye on with the number of tools that are out there. So really it is kind of unfortunately you go to their website and you can kind of get an idea of what whether or not this is fully open source yet or not. I am seeing here that the Plotly packages for R and Python and all of that are now open source, and that was a pretty recent development. So unfortunately, I don't have a more specific example or set of answers for you there.
Okay, thank you, Matt. Next question. If an organization uses SAS, is SAS data visual analytics an easy leap?
So the one limitation with SAS visual analytics is it's really somewhat, we haven't actually ended up using it in-house here, so caveat there. But the limitation we've had when we've talked to SAS about it is that it is really oriented towards bigger data and really comes with that idea of having a server set up behind your data that you're going to analyze. So it requires that extra leap of having a server and having someone to manage that server. So that's the big kind of expense leap. Unless something's changed very recently, that was the big kind of constraint for us.
All right, thank you. Next question. Do you see RStudio's Tiny App Server as a legitimate contender to Tableau and other solutions?
I'm not sure I'm familiar with that. That was RStudio App Server?
Yes. Tiny App Server.
I will say that I have used RStudio a fair amount for R programming myself, and if it is, as I would kind of assume, integrated with R and with the idea of using R, it's going to be difficult for that to become a contender with Tableau because of that kind of the effect that we've seen here of Tableau being very accessible to undergraduate students and people who are kind of a little put off by the idea of having to write code. So I would say any coding-based, in a general sense, any coding-based alternative is going to have some constraints in competing with Tableau because it's not going to be a direct competitor. The Tableau space is really about that kind of business analyst who's using Excel plus Tableau and perhaps not using any sort of code-based tools, so not using Python or R or anything like that to get deeper into the data. I think that there is definitely some space for somebody to sneak in and take some of the people who are willing to do that out of Tableau. That said, Tableau does have interactions with R. You can plug R scripts into Tableau to create and modify your data, but it's not required by any means to work with it.
Thank you, Matt. Here's another question for you. Is it generally easy or difficult to move visualizations from, for instance, Plotly over to your website? What's involved in doing that?
So it's generally pretty easy to do that. And I say pretty for one specific reason that I'll get to in a second. But most of these, Plotly, Tableau, Public, are all going to have a button somewhere on their website that allows you to get embed code to put it on your website. So ideally, you just drop that embed code on your website and you're good to go. It's very easy to integrate because what's ultimately going to happen is that the visualization is going to continue to live on Plotly or on Tableau or wherever, and all the interactivity and code lives there, and you're basically just linking straight through to it in your website. The caveat we've run into with that locally is that sometimes certain bits of security settings and things can throw your website off a little bit. We internally have a website service that's for students and faculty to create their own websites. It's available to anyone at UNC, but since it's run through UNC's servers, they've been pretty constrained about the security settings. It's based on WordPress, but it's kind of a constrained version of WordPress. That said, we were very easily able to get it to work just by putting it into an iframe. So if you're familiar with that, that's really just kind of putting a little bit of a box around it and letting it more explicitly go straight to that website. It takes away a little bit of your flexibility potentially, but it has worked well for us so far. So we haven't had any websites where we have been completely unable to get these things to integrate so far. Most of them are pretty straightforward and things that they're really designed to live on the web. So they are designed for you to be easily able to move it to a different website or embed it in a different website.
Okay, Matt, I believe we're about out of time. But once more, thank you for a very informative presentation. And thank you out there for attending our webinar. Just to let you know, we will be posting our slides shortly to our website. So if you want to download them, check back very quickly at healthworkforceta.org. We hope to see you again in the future. Thank you, and have a good day.